Hey guys, happy Wednesday. Earlier this week, you completed a POGL talking about limiting reactants, what happens when we run out of something when we're doing a chemical reaction. And so I just want to give you some formal notes on that and two practice examples. And then I also have a practice worksheet for you to work on with this as well. So what is a limiting reactant? The limiting reactant is the reactant that runs out first and limits the amount of product made by the reaction. So in the example we have here, we have 4 molecules of hydrogen gas, we have 3 molecules of oxygen gas, and when we react them, we use all 4 hydrogen molecules, but we only use 2 of the 3 oxygen molecules. That means the hydrogen is the limiting reactant because we ran out of hydrogen first. An excess reactant is the reactant that's left over unused after the reaction has stopped. So this little oxygen in the far right box wasn't made as part of the reaction. It was just left over from before, so it's still in there because it didn't chemically change. So we'll work through a little example to figure out the limiting reactant and the excess reactant. Sometimes there will be more than one excess reactant. And then how much water we can make and how much will be left over. So if we react 5 grams of H2 and 20 grams of O2, we can make some water. So the first thing we do is create a balanced chemical equation. It's always the first thing. So if we put in 2 hydrogens and 1 oxygen molecule, we can make 2 water molecules. So once our equation is balanced, we can start to work on our plan to solve the problem. First part of the plan is to use stoichiometry to find out how much product can be made from each reactant. So how much water can be made by 5 grams of hydrogen and how much water can be made by 20 grams of oxygen. The reactant making the smallest amount of product is the limiting reactant. All other reactants are excess reactants. So I've set it up here for my hydrogen, and we can see that we'll start out with our 5 grams. We're trying to get to water, that's our target. So we use the mass and our mole-to-mole ratio to get to our molar equivalency. 2 moles of hydrogen makes 2 moles of water, and then 1 mole of water is 18 grams. So with the 5 grams of hydrogen, we can make 89 grams of water. For oxygen, we'll start with our 20 grams and we'll do 16 grams of oxygen. I forgot to put my units. How embarrassing. 16 grams of of oxygen, 1 mole of oxygen, and then we've got our molar equivalents. 1 mole of oxygen makes 2 moles of water. 1 mole of water is 18.02 grams of water, the molar mass. And that means we make 45.05 grams of water from our 20 grams of oxygen. So if we compare those two, we can see that the oxygen makes less product. Therefore, oxygen is our limiting reactant. So we can only make 45.05 grams of water. Oxygen is the limiting reactant. Hydrogen is the excess reactant. There will be 0 grams of oxygen left over, because we're going to use all the oxygen until we run out. There will never be any limiting reactant left over. If for some reason you're doing something and you think that there's limiting reactant left over, you need to check your work because something janky is going on. Okay? Never should have limiting reactant left over. Now we want to find out how much of the excess reactant hydrogen is left over. So we can use the we can use the amount of product that can be made to calculate how much of the excess reactant is used. So remember, the smallest amount of product made from the reactants is the largest amount of product that can be made. So that means we're going to use that 45.05 amount to find out how much hydrogen is used. So we start out with our 45.05 grams of water that was made by the reaction. We use the molar mass to go to moles, molar equivalency to go from moles of water to moles of hydrogen gas, and then we use the molar mass of hydrogen to get to grams of hydrogen. So we're only going to use 2.52 grams of our hydrogen gas. So that's how much is used in the reaction. The next step is to subtract the amount of excess reactant used from the total amount of excess reactant. So we started with 5 grams of hydrogen and we used 2.525 grams. So now we have 2.475 grams of hydrogen left over. It's now your turn to practice. Hopefully the stoichiometry feels pretty straightforward at this point. Now we just have to keep track of what we're looking at. First problem I want you to practice is if 23 grams of dinitrogen react with 5 grams of dihydrogen, how many grams of ammonia will be produced? What is the limiting reactant? Okay, so first thing you're going to do, balance the equation. Second thing, figure out how much ammonia can be made by each reactant, and that will allow you to figure out how much you can make and what the limiting reactant is. So here it is worked out. I wrote out my equation. So 2N2 plus 3H2 gives me 2 ammonia. I'm going to take my 2 starting points, my 5 grams of hydrogen. I use my molar mass to get to moles. I have my molar equivalents. And then now I take my mass of ammonia to get the amount of product, which is 56.24 grams. Then I can take my 23 grams of nitrogen and my molar mass of nitrogen gas, 28.02, and then I have my molar equivalency, use the mass of ammonia, gives me 13.99 grams of ammonia as the product. So we pick the smaller amount, that's how much we can produce. And then nitrogen is the limiting reactant because it's the one that produced the smallest amount of product. Second example to practice, nitrogen monoxide reacts with dioxygen to form nitrogen dioxide gas. If 13.5 grams of each gas reacts, how much nitrogen dioxide will be produced? And how much of each reactant will be left over? So go ahead, pause this, try your best to solve this one, and then I will go over to the answer. Okay, write and balance your chemical equation. That's always our first step. 2 nitrous monoxides plus 1 dioxygen gives us 2 nitrous dioxides, nitrogen dioxide, sorry. We want to see how much we can make if we have 13.5 grams of each reactant. So we're starting with 13.5 grams of NO, molar mass, mole equivalency, molar mass of NO2. We can make 20.7 grams. If we start with our 13 grams of oxygen, molar mass, molar equivalency, and then the molar mass of nitrogen dioxide, we could make 38.82 grams. So only 20.7 grams of NO2 can be produced. And nitrogen monoxide is the limiting reactant. So we can already say with 100% certainty there will be no grams of nitrogen monoxide left over. There will be 0 grams. We still need to figure out how much of our excess reactant is left over, and so we'll look at oxygen. We'll start with the amount of product we can actually make and figure out how much oxygen we need to use to make it. So we'll start with our 20.7 grams of nitrogen dioxide, use molar mass to get to moles, mole equivalency to get to oxygen, molar mass to get to grams, and now we have 7.2 grams of oxygen are used. So if we take our 13.5 grams of oxygen that we started with, subtract 7.2 grams, that means we would have 6.3 grams of oxygen left over after this reaction. I'm going to be posting a sheet of practice problems as well. The answers are on there, but if you would like to see any of those problems worked out in detail, just mention it in the comments and I would love to do that for you. Hope you guys are hanging in there. I know this is getting to be long and tedious, but I love you and I'm here for you. Let me know how I can support you.